Hello, welcome again. We already discussed about Earth observations in the previous slide. Now I'm going to discuss about Geographic Information System. So in this lesson, you are going to learn about fundamentals of Geographic Information System. In short, you can say GIS, or you can also say it geospatial or geoinformatics. Yeah, there are many names, but mostly used name is GIS, Geographic Information System. These are the contents I'm going to cover. First of all, definitions of Geographic Information System, then overview of GIS, then key components of GIS, then data models and structure, then types of different GIS data, then geospatial data formats because there are many, and then overview of GIS analysis, then spatial analysis because we are talking about geographic information system. So spatial analysis is very important to understand. Then different applications of GIS. Definition of geographic information system. There are many definitions, so I tried to generalize the technology to understand the basic idea behind the GIS. So definitely we need a computer hardware and software based system to apply our methods. Okay, so basic definition of GIS is this is a computer hardware and software based technology and method to collect, store, keep in mind these words, to collect, store, manipulate, retrieve, analyze, and visualization of the spatial or georeferenced data. Spatial or georeferenced both are same because both are representing the Earth surface. Okay, this term we will going to discuss, don't worry. How GIS works. By the definitions, we can elaborate more about how GIS works. We visualize the data, we combine the data, then we need to query the data according to our requirement. So the geographical data that is stored in the databases are visualized on GIS software. Like we are going to use QGIS software, so we are going to visualize all the created data which are stored in our system as a database. Okay, that is very important. Combine the data, or you can say couple the data. Okay, we have different kind of layers, thematic layers. So we have to combine by using the different functions and method like overlay functions according to applications. Okay, in the form of map and web portals. Definitely we need maps as an output or maybe in the web portal form. Then query, because we have very large number of data maybe, but you want to select only your interested data and you want to display only what do you want to see for your analysis, right? So you are displaying the data from the n number of GIS layers attributes by the searching a unique values, right? So you remember this picture. This is overview picture of our course on the GIS, right? So this, if you understand this picture, you will get the whole fundamental of GIS, at least on basics level. right? So there are three words: geographic information system, right? What is geography? Geography talk about human and environment, and how human and environment has impact on each other. Okay, and we are the people who living on the earth. Okay, so we are also finding the interaction with the earth. Okay, so geography is about the study of the earth surface. Majorly we consider three words: where, what, why, 3W. So where, in the geographical term, we always talk about geographical coordinate. This is the most important. Then we can go for address like annotations. Then what? On that coordinate, or maybe on that location, what information is available? Means about the features on the earth surface. Why? Why those features are there? Why they are developing? Okay, these kind of things we are finding in the geography. Okay, then we are finding those things in the form of information. Okay, so data or information you can collect in the form of spatial or non-spatial form. Okay, data can be usable or maybe non-usable. We just collect the data, but then we can filter the data according to our requirement, then it become information. Okay, so here you can see the spatial data, as we discussed in the earth observation slide. What is raster data? Image. Okay, here I am showing the three raster data: aerial photographs, topographical map, and satellite images. So all these are in the form of pictures. Okay, it means they are array of pixels having the DN value. Okay, having the reflectance value. Okay, you can see the structure of raster here. Okay, they have row and columns. Okay, and then we have digital numbers in the all pixels. And then non-spatial data. Here you can see attribute data. Okay, here I showed one example. We collect the many data from the ground, asking the question from the people, like household survey, livestock survey, population, demography. Okay, so this kind of data we call it non-spatial data. Definitely we collected the data according to our requirement, but we need nowadays a system providing insightful and meaningful outputs according to users requirement. So system actually arranging your data. As you remember your definition, we are doing these things like retrieving, analyzing, generalizing, storing, and manipulating the data, where we are doing all these things in the computer hardware and software. Okay, here we are using the QGIS. There are many, but here we are using QGIS software. Okay, for what? For spatial analysis, for classifications, for watershed delineation. There are many. These are the broad analytic things we are going to do, or we have to understand. And I'm showing some examples here: digital elevation model, then a final map, and this is false color composite. Okay, false color composite is we are using the false color on the satellite image. Okay, green actually showing in the red color, because we are shifting IR to the red and red to the green. That's why all green cover reflecting in a red. Okay, then we are going to do LULC map. So this is the whole pictures of GIS. You can understand. Yes, key components of GIS, as we discussed before, about data, computers, users, methods. Okay, so these are the 5 important key term. We need hardware, first of all, then we need to install the software, then we need data like non-spatial, spatial data. I'm showing some pictures as example, then people like workers, manpowers and users. Okay, then methods, different spatial methods or geostatistical methods to analyze the data. Okay, yeah, data models and structures. So as we discussed, we have 2 type of data models, spatial data model and non-spatial data model. Spatial data model, you can see the pictures here. This is LULC map. Okay, this is just a reflection values. We convert digital number to a classifications, then we give the classes like different land use, land cover classes. The yellow is showing cropland areas and red is showing the settlements or city or urban areas or village areas. Then light green is showing the scrubland or open forest areas. Okay, so this image is a spatial data. Okay, definitely we can use annotations or legend to show the information regarding this map. And then non-spatial data, definitely we need to calculate the area and other kind of demographic data with this map. So we have attribute behind this data. Okay, so analyze the statistical things. Okay, yeah, types of GIS data or spatial data model: raster data and vector data. Raster data mostly coming from the satellite, from the airborne platforms, okay, in the form of pixels. You can see the highlighted pixel 1, 2 and 3. I'm just showing some examples. We have 3 classes, so every class is just in the square because pixel is the grid. Okay, and raster is actually array of the pixels and each pixel is stored digital number. So when we classify the image directly by using the classification techniques, so we also get the output in the pixel form and we just classify them. Okay, but in the vector, we digitize the point, line, polygon over the raster data. Like a drawing, we are drawing the data. Like here in the raster, you can see the pixel. But if I'm just drawing a line here, like a drawing. Okay, so this is like I am digitizing a line to extract the river. Suppose this is blue pixels are showing the water or a river. So I'm just drawing the line. This is line entity of the vector data. And if I am putting just a point like this, okay, maybe we can change the color. I can take green. Okay, like point. So this is point entity to store the point locations. And then we have area. Suppose we have forest area and I'm just drawing the line on the boundary of forest area. Okay, so this is like polygon entity. So what we are doing, we are just generalizing. Here you can see in the map roads, locations, water bodies, not in a pixel form but in a vector form. I hope you get it. Data formats. So when we are going to work on rasters and vectors, so always keep in mind, if you are opening any data in the QGIS, and if you are importing or exporting the data in the GIS, always check the format, in which format you are saving your data, okay, and creating the data, okay. So there are many and number of extensions, but here I am just using the mostly and widely used data formats. So this slide showing the raster data format only. So extensions, ADAS imaging, when you see the .img format, this is like ADAS imaging extension, like .jpg we see for the pictures. So this is .img. Okay, when you see the img, it means this is a raster data. This is developed by Hexagon Geospatial World. This is like very a big company, organization you can say, worldwide. It can store single to multiple band of satellite data. Then .asc, also called American Standard Code for Information Interchange, ASCII grids. Okay, so it can store the numbers from 0 to 255. Okay, then you can convert it to in another format also. Okay, this is generally in the comma or space or tab delimited format if you see the axles. Okay, so you can convert this data, ASCII data, to the raster. Okay, GeoTIFF format very popular nowadays after IMG. Okay, there are three extensions when you generate the TIFF data, or when you are exporting or importing the TIFF data. There is another format you can see, TIFF or .ovr. Okay, so GeoTIFF data actually same as IMG, and there are another extensions you cannot ignore, because like OVR is a pyramid file. Pyramid means it's matching the histogram of the satellite images in your system. Okay, so in the simple word, it's enhancing the colors, so you can see the color very clearly in the satellite image. Okay, Idrisi raster.rst, this is also a raster format. Okay, then INV raw data like bill, BIP, this is like very old data format. Nowadays these are not in the like not more popular. And then ISRI grid, this ISRI grid is still in the use. Okay, ISRI grid file are integers and floating points grids actually, and land cover would be an example of discrete grid. Each class has unique integer cell value, right? This kind of data. And then vector data formats, like when we generalize the data from raster to vectorize, like vector, like point, line, polygons. So most popular extension, we are also going to use it, .shp. This is ISRI shapefile. These four extensions are very important. Never ignore. If you are copying the shapefile data in your system, always check you have all these kind of formats inside. So SHP actually is storing the geometry, means drawing, whatever you are drawing. This is SSP. SSX, this is index position actually. And DBF is a database. Actually, it is like whatever you are typing in the attribute, it is storing in the DBF format. And PRJ means projection. If you don't have PRJ, then your data need to be project. Okay, another extension is GeoJones, you can use for web-based mapping. Then KML and KMZ, sometimes you can use Google Earth, and you can digitize some objects on the Google Earth and you can import into GIS platform. Okay, and .gpx, especially when you collect the data using the GPS from the ground, so it would be in the GPX format. You can always use this GPX data directly in the GIS platform, and also you can convert in another extension like SHP. And then OSM. Nowadays people are using the QGIS, like OpenStreetMap plugin. You can convert PVF to OSM easily. Okay. Then arc info coverage. This is very old format. Arc info coverage are a set of folders content, point, arcs, polygons, and annotations. These are the vector formats. Then I'm telling some spatial analysis things, which is because we are going to do watershed analysis and indices mapping and LULC mapping. These things are also part of spatial analysis. But basic things you need to understand. Okay, I'm not going to teach you all the spatial analysis, but I'm telling the basics of spatial analysis. Spatial analysis is a process in which you model problem geographically. It means it's a location based model always, and drive result by computer processes. Okay, you need tools and methods to do this, and the explore and examine those results. Okay, so following problem you can resolve by the spatial analysis in general. There are many, definitely. Always keep in mind there is no boundary, no constraint. There are many, you can explore yourself. The pattern detections, the space-time analytics, predictive analysis, suitability modeling and location optimization, route planning and logistics, terrain analysis, scale up your analysis, right? These are the things. Now I am elaborating about the tools and methods of spatial analysis. There are many kind of spatial analysis. So spatial interpolation. What is spatial interpolation? Means we have lots of point data, like you have gaseous data from the ground, right? And you have some sample points from the ground. So you want to create a continuous surface instead of points. So you can do interpolation. There are some interpolation methods I'm showing here. This is in polygons, triangulation, irregulation networks, spatial moving average, trend surface. Then geoprocessing tools. There are buffer, union, intersect, dissolve, clip, and many more. So what you do in the buffer, suppose you have a point location and you want to find the affected area of this point. Okay, so what you do, you want to create 5 kilometer buffer along this point, right? You have 5 kilometer radius. Okay, so during the during the analysis in the tool, you just give the 5 kilometer radius. So what you will get, you just get a sphere like this, 5 kilometer sphere around the point. So you will get the value and you get the area, affected area on this point. Okay, you can do it on the line, on the polygon in the same way. Okay, and then union. In the union, suppose you have two vector file storing the different kind of data, like this is one, this polygon file 2, 3, 4. These are different classes, and you have another file. This is storing different classes, right? Like 5, 6, 7. So when you apply the union, you will get your output in a single file. Both are separate, but you will get the output in the single file like this, and you will get all these values like this, right? 1, 2, 3, 4, and those values also. Okay, so what they are doing, they are combining the layers including attribute. In the intersect, they exclude the unique areas, okay, and just include the common areas. right? And other things we are going to use during our another session, so I'm not going to show here. It is taking too much time and you are not going to understand much, so we will do it practically. Okay, so I'm just giving the idea how geoprocessing tool actually works. Okay, then spatial geometry, definitely thistle polygons, you can do the spatial geometry in it. Centroid is very easy. Suppose you have polygons like this is shape file, vector file, and you want to get only the center point, you don't want the area. So when you apply this tool, you just get the point, and you will also have your attribute whatever you mention in your shape file like this. The other area will exclude automatically. You will just get output in the point, in the center area of the each class. Okay, and then polygon to line, definitely you can convert polygon to line, you can convert also line to polygon. Sometimes you need to simplify because when you do the vectorization, suppose you have the raster data like pixel form and you have to, and you want to convert into vector. So what happened, you will get output when you do the raster to vector. Suppose this is raster, okay, and you just want to extract these 3 pixels, so you will get the vector file like this sometime. Okay, you can apply this tool in the line and polygon, not in point, definitely. Okay, so what you will get, instead of squares you will get a simple line. Maybe you will lose some geometry, so you have to keep in mind, you have to check your geometry. Okay, that is the things sometimes we use to reduce the vertices, reduce the, and also create the seamless data. And other kind of raster analysis is slope. You can create slope by using the DEM, and you can also create the hillsides, aspects, and different indices, land use, land covers, right? Yes, watershed delineation, different indices, land use, land cover. Okay, then GIS applications. So there are many GIS applications. You guys are from different places, so you can use GIS in your field, in your profession. Land planners also use GIS, so you can do land planning and management. You can do network analysis like road planning, canal planning, river channel planning. Okay, especially mostly network analysis, very useful for road mapping, right? Watershed analysis, we are going to do this. Site suitability mapping or site selection, right? Suppose we are going to do tiger habitat suitability maps. So when we extract different kind of thematic layers, so we can get the idea of the highest suitable areas for the tigers by using the different aspects and themes. Okay, and suppose you want to select the nuclear power plant location, you can also use different layers by using the GIS. Okay, then incident mappings, then spatial measurements, you can also measure the all kind of geometries in the GIS platform. Topographic analysis you can do, demographic analysis you can do, agriculture water management, like how much water required in particular field, you can do by using GIS applications, sorry, GIS uh, tools. Then disaster mapping you can do, and transportation modeling and resource exploration you can also apply GIS. And these are the references. You can find in the libraries, and you can also find many online resources to increase your knowledge in the field of GIS. Thank you very much, and thank you for your patience. I'll see you next in the next slide. Thank you. Bye bye.